reaction types as found on Fall 19, Test 4, Part 1. I didn't copy that over, so that's what we have here. Previous video, current video. And we got to figure out what's going on here. Well, it looks like somehow this became a leaving group and it gets replaced by this somehow being a nucleophile, right? Because that's what happened. Here's the CH2 right there. So what do you call that? I mean, you could think of it like it looks like a backside attack, maybe. Are there any things that kind of fit that? It's not a conjugate addition because it didn't attack and a pi resonated to somewhere else. It didn't do that. But it's some kind of an addition reaction. Addition. There you go. Addition. Is it really an addition? Or so, is there a substitution? Electrophilic aromatic. Oh, wait a minute. Yeah. Addition. I don't know why I even mentioned addition. Addition's when you do things like AB reacts with C to make a molecule that has all of them, A, B, and C together. That's addition. We didn't have that. This got replaced, right? It got substituted. So it's a substitution reaction, and this is an aromatic ring. If you look, hey, it's aromatic, right? It's got the benzene, it's got the lone pair here, and we're putting a group on an aromatic ring. We call that electrophilic aromatic substitution, BC. That's our best choice. And then what's going on here? We have, wow. Oh, wow, yeah. So we put a hydroxyl onto here. That's an aromatic ring again. So maybe it's also electrophilic aromatic substitution. Anything else? I'd probably give you credit for, is there oxidation here? Because it is an oxidation too. I would accept either answer. Oxidation. Now, if you're going to pick one of the oxidations, you better tell me you know what kind of functional group was involved. Is an alcohol polar or non-polar? Polar. Which chemical oxidizes polar functional groups, NAD plus or FAD? We mentioned it in class the other day. NAD plus is for the polar functional groups. BD would be your answer. I would also accept BC or BC because we did substitute an H for for an O, for an electrophilic O, and it's on a benzene, so it's electrophilic. What's going on in the next one? Oh, this goes away. This goes away. Plus CO2. And it got replaced by an H. Okay, so we lost a carboxyl group. Is there any words that say we lost a carboxyl group? I see one, don't you? Right there. Decarboxylation, very common for amino acids. Yeah. And then what's going on here? We're transferring NHAC, I want to remind you. Is this. Yeah, didn't circle that very well. Got the CH2. There you go. And that's an amide. And this used to have an acetyl group here. And now the acetyl group is here. So what are we going to say? What kind of a group is an acetyl? It's a, I don't know, oxidation, retro, aldol, no, 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 no. Do I see it? Do you see it? It's not a dehydration. It's an, you can call it an acylation because this is an acyl group. But I don't see acylation on there unless I missed it. Question. Condensation. Condensation. Let's see what we did. We made this molecule bigger, right? We got a bigger group on there, and we lost a small molecule. I guess that's our best choice. Small molecule lost to make a larger molecule. And I had trouble finding anything else close, so I'm pretty sure it's condensation not covered by any condensations below. Yeah, that's choice E. And then 15, what's going on there? We're making an ether. An ether. Yeah. So we're getting rid of an H and putting a methyl in its place. Yeah. What do we call that? SN2, if you want to think about that. But do we have a substitution up here? Substitution. Yeah. S stands for substitution in SN2. ADE. SAM is S-adenosylmethionine. And it's kind of like your biochemical CH3X. You see it a lot. Methyl with a leaving group. If you see SAM, that's what you think, okay? And you've got it right. And nucleophiles, the predominant use of SAM is for nucleophiles to hit that and put a methyl. Methylation plays a large role in things like epigenetics, where your DNA actually changes during your lifetime. Further makes everybody unique, you know, everybody's in a different environment. And when DNA gets methylated, it's new, it's altered. And SAM does that too. We got another SAM going from here to here. What's going on there? Hey, we're getting two methyl groups on a nucleophile this time. It's the same answer. It's a substitution on a different position. Instead of using the O, I use the nitrogen. And ADE. There you go. And we'll do some more of these on our next activity. I guess we can do it when we come back. All right, resuming with a similar type problem here. Same answers for this. And here, you're getting rid of two H's. Getting rid of two H's, one of them from here and one of them from here, and replacing them with bonds to more electronegative N and electronegative C. That's an oxidation. Yeah. And the only question here is, whenever you lose minus H2 or plus H2, that one's oxidation. This is reduction. So if that's the change in your molecule, where you either lose H2 or gain H2, we're talking oxidation or reduction. Now, I'm probably going to be flexible on this because an imine is only slightly polar. It's kind of borderline. So I believe this is an FAD reaction where this is oxidation because we're losing H2. So you're down to FAD or NAD plus. But I'm going to say that FAD is my first guess, BE, but I'm going to give you full credit for oxidation with NAD plus because it's not a very polar functional group. It might be either one. You could do some research and find out which one is the biochemical one, but in this case, I'd cut you some slack. Because what I want you to remember is the broad concept. If you want a biochemical oxidation of a non-polar functional group, you better use FAD. If you want a biochemical oxidation of a polar functional group, you better use NAD+. And this is not that polar, but it's borderline. All right, now, hey, you're cutting this thing here. You're making H3N+. Hey, what molecule is needed to cut that and put 2 H's on the N and 1 O on the carbon? That's water. Hey, it broke apart using water. Is hydrolysis one of our choices? Gosh, I hope so. Where are you, hydrolysis? Show your head. C. And then definitely replacing a bond on a polar functional group from H to an O. That's polar oxidation. Which chemicals are required for polar oxidation? It's NAD+. And then we're doing, we're making a bigger molecule and losing this little guy. We did that on our previous condensation. Where'd you go, condensation? Not covered below, E. Not a Claisen or an aldol. And then I'm losing CO2 again. That seems to be a popular theme in biochemistry, huh? Losing CO2. Decarboxylation. And then I'm cutting this. You're going to make a HS-CoA. You get this. That's hydrolysis again. Hey, ladies and gentlemen, please remember, this is a derivative of a carboxylic acid called a thioester. This is a carboxylic acid in its deprotonated form. That's what makes derivatives derivatives. When you do hydrolysis, you get the carboxylic acid back. There's your answer. Hydrolysis. Where are you, hydrolysis? We saw it already, didn't we? There, C. And then we're adding CO2. We're bringing in CO2. Yeah. I don't know. We call it decarboxylation when we lost CO2. Is there a carboxylation answer? I don't think so. We are making a bigger molecule. It looks like it's a straight up A plus B goes to AB. A plus B goes to AB. But we lost H plus as well, didn't we? We lost H. There's an H here. So you can't say it's a condensation. You can say it's an oxidation. Replaced a bond from C to H to a more electronegative C. Because I don't see any big good fits there other than that. And it's definitely polar, a CO2 minus, right? It's polar. Oxidation using NAD plus, BD. And what else we got? So we're going to coming down here. This combines with this to make this bigger molecule. All the pieces here are here except it lost its H. And here lost O. And it's this, no, it's this one. They condensed together. That's a condensation, not an aldol. It's not a Claisen. So it's an E. Good catch-all E. I think E's been our popular answer. I got a prediction. A prediction Monday. I'm grading these tests. And I said, hey, somebody put E for all the answers here. I wonder why. Yeah, because they wanted to catch a couple points. That's why. There's no shame in that strategy. You know, if you want to save some time, get at least a few points. I have no objections to using that strategy wisely. It'd be better to understand, wouldn't it? Now, this is a classic with what sulfur does. This SH and this H combine to make an SS. You'd like to call it condensation, but it's not because you're losing two H's. Not a water, no, two H's. When you lose H's, here's your theme, guys. Losing H's is oxidation. Gaining H's is reduction. It's a good theme. So we lost H's. It's an oxidation. Please be careful. Thiols are not polar at all. 2.5. What's that mean? Carbon, sulfur, iodine all have an electronegativity of 2.5. When it's bonded to hydrogen, it's not polar at all. So it's a non-polar oxidation. Which chemical do you want to use? You want to use FAD. And there you have it. So we learned some things about biochem there. And we'll move on.